Hey, we can all be on a first name basis, I think. I'm Frank. What's your name?
Karen.
Ken? All right. So it looks like we almost doubled our attendance. So I'll just go through this fairly quickly. It's meant to be pretty high level. It's not meant to be like crazy nuts and bolts under the cover stuff. But what we'll work our way through here is this sort of quadrant. This will be sort of businessy stuff. This will be technical-ish here. We'll just sort of work our way through it and then sort of see why what we're doing is effective and what we're doing is important. So we know that everybody today is really, the things that value are attached to is really the apps and services that you guys can deliver. Value is not attached to the cost. Value is attached to what you can deliver through an apps and services standpoint. And like most people, those apps and services are really like growing. I mean, they're maybe growing quickly, maybe growing slowly, but they're certainly not like we're just peeling back apps and services. Maybe in some cases, I guess, we're getting rid of things like Exchange to go to Office 365, but for the most part, there's a lot of like growth up and to the right. And all that stuff is kind of built on the back of the two major costs of the data center, which are compute and storage. Networking, I mean, it's not the one that really breaks the bank most of the time. It's typically the compute and storage. So that's the kind of cost. If there's sort of a parking brake financially in the data center, it would be the cost associated with compute and storage. Fortunately, virtualization came along, and we've been able to sort of slow the growth of compute, the spend of compute, and we've also been able to sort of slow the spend on it from an OpEx standpoint, how many people it takes, how much time they spend on the compute side. So it's been a reduction center from a cost standpoint to be dealing with virtualization, but that trend's kind of flattening out. I mean, once you're 100% virtualized, and it's virtualized first, you're not in this massive reduction phase anymore. You're just sort of in a slower growth phase. Unfortunately, though, on the storage side, because of the explosion of data is like growing way, way faster than the applications even. We're still seeing an up and to the right trend for time to manage storage, time to manage the storage of VMs, and then also just a huge, huge dent in most budgets that comes from the storage side. So we see mostly about 60% or up to 60% can be tied up in the storage for a data center pretty easily. So it's the one key threat to the ability to continue delivering those apps and services at a pace that you guys are being asked to deliver. So bottom left. So today, the things that really matter, those apps and services are typically tied one-to-one or many-to-one to a VM. And what's really important is to be able to manage the performance of the VM. People will call you if it stinks. To be able to manage properly for those VMs at the right level of granularity, and then to have a fair understanding of what the cost and the value of those VMs is. And what we're dealing with on the technical side of this, though, is that all VMs, pretty much all VMs are different. They have different performance characteristics. The applications that are written on top of them have different performance characteristics. So they're all different. However, they're kind of shoved into this LUN world. Sorry, here's the technical thing. Everybody with me? Nobody's like faking from this technical stuff. So they're all shoved into that LUNs construct, which is like 20, 30 years old. I mean, LUNs were around long before VMware and virtualization, and it's still the same LUNs like buckets for shoving all this stuff into. So what you get is kind of like this mishmash blend of all the I/O and all the performance of all the VMs, meaning that now performance of the VMs, which is a key thing that you care about, is kind of unpredictable, brittle. It can change with the very next VM you put in. Maybe everybody's fine in that LUN, you put a noisy neighbor in and you got problems. So performance is off the table with our traditional storage underneath virtualization. The other piece is that from a LUN standpoint, you're really tuning at the wrong level. You're tuning, you can maybe add disks, you can change the RAID type, you can do all this other stuff like the coverage, but tuning is at a LUN level. We're not able to actually tune at a VM level. So the tuning piece for us, the manageability piece, is blunt. It's too coarse of a tuning knob really to affect the performance of an individual VM appropriately. And the final piece of it, at least in the spinning disk world, we run into capacity versus performance issues. So we'll get to some capacity, 60, 70, 80%, but typically it's very rare we get out to 100% utilization. And a lot of people are out there, we talk to at least 2 people a day, so they're buying more shelves just to put more IOPS into their system. They're never going to be able to put storage on that IOPS, so, like on the shelf, because all they're doing is supporting performance with a bunch of empty space. So we're also kind of like blurring and messing with our ROI models. We're not getting the value we think we're getting out of those VMs. So for the storage teams out there, the storage admins, they're kind of stuck in this like best guess prediction. That's from buying the storage to putting the right VM on the right storage. A sort of fingers crossed, deploy, and then lots and lots of time with fixing. So it leads to this like bad predict and fix cycle. It makes everybody a little bit more gun shy, a little bit more hesitant about pulling the trigger the next time for the next application or buying the next array. Well, last time we had to go back to the vendor and buy a bunch of SSD because everything was slow. We had to buy a bunch of spindles because everything was running out of performance. Those things start to really paralyze shops, and that's another drag on sort of the growth of the applications that we're trying to support. So we see that a lot of vendors are recognizing this problem. We've had performance issues for a long time. We've had manageability issues for a long time. We also have So some people put all flash into an array. If you don't have very good visibility and you just throw all flash into an array, that can help. That can provide an incremental improvement in performance. There's some other pieces to that that aren't helping us get the best performance necessarily, but it does help. It's just not very economical. Some manufacturers will come back and say, well, thanks for buying our array. How about this analytics package? So there is an attempt to do some more correlation. But the bad info at just a LUN level is still bad info at a LUN level. You just added more info around it to try to sort of pad that, mitigate that lack of visibility. But again, it's really just sort of an incremental step. We're not talking about anything dramatic. And then a lot of companies have really tried to go after this value portion of it by using just software-defined storage or commodity hardware. We've got phenomenal. Inside of, say, the EMC array, there's an Intel chip, and there's some hardware you can typically pull together off the shelf. Or inside an Exhibitor or something like that. It's just selling the software and you put it on any hardware. They're trying to go after that. So they're using this commoditized hardware to build cheaper arrays. And that's one more component trying to drive a little bit more value on the cost side of it for the VM. But for us, really all those approaches are kind of they're sort of isolated from each other. Even if you stitch them all together, it's not a comprehensive solution. It's not it's piecemeal. And they're sort of isolated from each other. So what we're really trying to talk about here is storage that is VM aware. We're trying to, Tintri is taking the approach of, what if you extend the visibility that you have on the host side? On the host side, you get graphs all the time, CPU and RAM, you get all this great detail. On the storage side, you see how a LUN is doing. It's a heat map. So this was red, and that LUN's green, and that's about it. So we want to extend that same granularity all the way down into the storage, and that's what we're talking about here. So we want to say, let's assume all workloads are different. We'll provide them essentially with a virtual volume that VM can sit in. Now, instead of being tuned for the middle, we're actually going to be able to tune for each individual workload. So now, something that's write heavy needs different performance behavior than something that's read heavy. So we'll tune individually for that. And what that virtual volume sort of environment does is it provides isolation for all the VMs. So now, instead of having a bunch of noisy neighbors conflicting with each other, interfering with each other and causing degradation of performance, we can keep those VMs apart from each other just by the virtue of putting it on a Tintri device. So that dynamic QoS is actually now dynamic and manual. You can actually set QoS policies on an individual VM if you like. So you can keep dev VMs quiet, production VMs warm, whatever you want to do. So now, this is meant to be like a little performance heartbeat that we saw on the earlier slide. That performance is now tuned and characterized individually per VM. And then the other piece we can do with this is just allow that same one big chunk of storage to talk to multiple hypervisors all at the same time. So now, you hear about like evals and things like that from VMware, people that are VM aware. Tintri started with VMware and then moved on to Red Hat, or moved on to Hyper-V and Red Hat, now OpenStack, and then soon Zen Server. So now all those features that are VM aware are universal across a range of hypervisors. All at the same time, you can plug in one Tintri box to Hyper-V and one to VMware at the same time. So instead of this isolated approach, this sort of piecemeal approach, by building our system to be VM aware, we're able to get like orders of magnitude improvements. We're talking about like 50x improvement in performance. And we measure performance typically by latency. We aren't talking about top line IOPS. I mean, once you get past 50,000 or 100,000 IOPS, I mean, most environments aren't even asking for that. It's pointless to be building 200,000, 500,000 IOPS into a data center that's going to require 10. But if your VMs can't get to it, you're going to experience latency. If they're all jammed up, waiting behind each other in line to get to that storage, you're not going to be able to utilize it. So for us, a performance improvement of 50x is more of a reflection of, say, 100 millisecond latency down to 2 millisecond latency, or 50 down to 1. And then for us, manageability, we have shops running 55, 56 Tintri arrays with like 2 man-hours a week. That's on the high end of scale. I mean, I recognize that everyone in this environment is probably more like, they have 40 man-hours a week to deal with. There's probably one guy who's trying to like run around and do with all this stuff. If you can reduce the amount of time that you spend per week by 60x, that's a massive, massive return on your time. And then we also have people saving just tremendous, tremendous amounts on their CapEx and their OpEx, just because one Tintri box can be as small as 2U, it can be as small as 4U, and it can hold 90 to 100 terabytes in 4U. So now power, cooling, maintenance is flat across 5 years. We're not talking about huge, huge investments here. We're actually able to reduce a lot of data center utilization and expense. So back to this slide here. Now, the prediction piece, because we're VM aware, because the OS is learning what each workload is doing, the prediction piece is gone. You don't care. You can put anything. Can we virtualize this? I don't know, the vendor says to support it. Yes, we don't know what kind of performance characteristics it requires. Who cares? Put it on a Tintri, and the Tintri, the OS will learn how to adapt to those workload requirements. And then the fixed piece, again, because you don't have to predict, you also don't have to fix. The OS is taking care of optimizing performance for each VM, or each VDIS even, without any interaction. So now you're spending your time back in the middle of this cycle on the deploy portion, which is that up and to the right of your apps and services growth. So now we're back here. We're trying to drive that OpEx way down, trying to at least reduce the slope of the CapEx growth. And then we're also trying to return a little bit to the growth curve, the apps and services. I went real fast and like real high level. I hope it wasn't horribly technical, is it? Is any of this out of line with what you guys deal with? Or I mean, is this about the terms you have to think in at this level, or?
I was saying you're putting in the Tintri unit in order to keep having to invest in so many extra drives and things to keep the system running. So.
Yeah. What we really want is for customers to run out of capacity long before they run out of performance. So we feel like it's a more common sense approach for the day-to-day storage admin and whoever's signing checks to sit down and say, we ran out of capacity, we should get another one. Like, that's real easy a conversation to have. Not, we ran out of I/O because we didn't spec it for this application properly. Now we got to go back and get more disks that we'll never be able to use the capacity on. Or, conversely, we are at 70%, so our performance went off the table, and now we have to get more capacity again. Like that blows ROI models up all the time. It makes people gun shy. It makes it really distrustful. It just makes the whole process really hard to standardize and stay confident in that process. So what we want is just lots and lots of speed, the proper performance for every disk with the minimal amount of time. Most of our customers install these themselves, so there's not like a ton of professional services. So if you have the one page of information you need, like NTP and settings within your data center, and walk into the data center, you can unbox and rack a Tintri yourself in 30 to 60 minutes. The 2 times I've ever been asked to come in and help customers rack their own was because it was one guy who was scared to lift it by himself. So it isn't rocket science to pull these in. It's not like it requires the PhD in storage who you're super scared is going to quit tomorrow because he's the only guy who knows how to manage it. And you know, and managing the storage is really only half of it. Managing the storage is one thing. Managing the VMs on the storage is a totally other thing. So in both instances, Tintri is really trying to take a swing at that and say, well, if you write the right kind of file system, you write something that's VM aware, you don't really have to do either one. The OS will take care of both sides of that for you. So I try to keep it really short today to keep I know I'm in between everybody and beer, so I'll give you back whatever time you guys need, but thanks a lot. If you all have questions.
Yeah, what about your traditional SAM fillers, like your exchanges and your SQL Server-based ERP software? Do these have effects on it?
I would say probably about a third of our customers start there. They start with problem applications. So we write tons of papers on best practices with all kinds of different SQL deployments on Tintri. Because what's unique about us is, let's say you break up the different pieces of a SQL box into different disks. We'll learn the performance characteristics of those disks and optimize for those. So now you don't have to have a RAID 10 one for logs and a RAID 5 for the database and all that kind of stuff. Well, thank you. So it just learns it for you. So that's really what we kind of like that. We like those cases. But I would say 1/3 people start with things like VDI. Another third, people start with just virtualized infrastructure. Maybe another third, people are looking for a way to solve problem applications, because the other piece of this I mentioned is just visibility. We're able to see what's happening on the host. We have a latency bar graph. It's color-coded into segments. This is host latency, this is storage, network latency, this is storage. So now, some people are just using Tintri for better troubleshooting. It does give you an added benefit of performance, but there's no storage out there that will actually give you an end-to-end look at what's happening to the whole data path with VM. So it's really powerful. I mean, there was a really widely discussed case internally where we were up against somebody who was all flash. The customer put the SQL or whatever it was on the all flash, and things didn't get better. They put it on us, and it got dramatically better. So we're all like, yay! And then, because of our visibility, we realized it was a host misconfiguration. So we fixed the host misconfiguration, put it back on our competitor, and it ran super well. So, you know, in the end, we won that deal because we provided the tool that helped them solve the problem, not necessarily the SSD. It wasn't about hardware. It was really about the ability to see what the problem was and do it really, really quickly. So we love it. I mean, we'd say bring them on. Like we're really happy to take those kinds of workloads because they have been such, VDI is notorious, especially for raising lots of questions about how many power users and when do people log on, when does all this stuff happen. And you just have to be like Nostradamus to know all this stuff. And like, then you really have to build for some high watermark, the worst day at the worst time. You pay all this money for that speed, and then the rest of the time you're just overpaying for your VDI environment. So, and a lot of VDI projects are stalled because of that very thing. The storage part of it is very hard to know and hard to guess in advance. It's that predict part. I can't even predict well enough to know what to buy, much less put the VMs on it. So Tintri's really got a lot of traction out of customers from well, you don't have to know, just put it on there. And now we have even manual QoS, so that the isolation keeps them from fighting with each other. Gives all the VMs sort of the sense they're the first and only VM on the array. And then by being able to do manual QoS, we can even tune that more granularly and say the VDI sessions need to have a cap of 250 IOPS because nobody in their right mind doing VDI opening Word, Firefox, and Chrome needs to be doing all kinds of I/O. We don't have illustrators in our shop. We don't have video editors in our shop. More I/O than that means they're plagued, you know. So you know, we can do some controls like that to really help those workloads a lot.
And you can load Exchange up. It's not like an NFS box or anything like that.
It is presented over NFS, but we have tons of customers putting Exchange on it today. Exchange and SQL. It's presented over NFS because the whole box is built on a proprietary file system that allows us to see at the VM level. If we present it over block, you have to sort of bring your own file system, which would be something like VMFS, and that's the very problem we're trying to solve. So we kind of undo what we engineered. So if you guys want any other information or whatever, we're in the booth over there, kind of near the snacks, but and then we can always do a demo too. I mean, demos are quick and easy. It's how's the box doing? How's the VM doing? There isn't a how are the lungs doing section. That whole middle chunk is gone for us. So one box in your data center is one data store, and that's it. So thanks a lot for hanging in there, guys. I'll see you guys on the floor.
Thanks.
Thank you.